Okay, so you're getting pretty close to ready to start your experiment. What we need to do in this experiment is we need to make sure that we are careful with the treatment of each group. So basically, what we're going to do is we're going to be throwing airplanes of different types, and we're going to be determining if those airplanes or how far those airplanes are going, or depending on what else. If you're doing a different form of best, remember I'm talking in terms of distance, because I think that's what most people will choose. If you really want to choose something else, go for it. I'd like to see you branch out and do your own thing. But if we are gonna do it, we need to be sure that our treatments are good. So really now we need to talk about data. So what is data? What is observations? What is all of this? So this is really the most important part of the experiment. And the reason for that is this is what gives us the information we need to draw the conclusions that we're looking for. So in terms of data can be observational data, is just simply 5 sense observations. What does it feel like? What does it smell like? What does it look like? What does it taste like? Those are just observations that you can make that are essentially descriptive of the process. So those are going to be qualitative measurements. Now, since we just used the word measurement, it's probably a good idea to determine what a measurement is. And so going back to your other science classes, a measurement requires two things. If you were here, I'd ask you what are those two things, and you would fumble around and you would say, it's a number, and I would say, yes, I am 5. And if I say I am 5, what are we talking about? We need the other part of that measurement. I could be 5 years old. I could be 5 feet tall. I could be 5 tiles tall. I could be 5 fingers short of having 15 fingers. So you need that descriptor after the number to really give us a good measurement, right? So measurements then are going to be a number and that little thing at the end, that descriptor, that qualitative piece that tells us what the number means, and that is going to be a unit. So a good measurement is going to be a number and a unit. So we have measurements and we have observations. A measurement is an observation. It's just a more detailed observation, or a measurement is probably more of an observation that is quantified, so we know exactly what it means. So that's where we get into quantitative versus qualitative. Quantitative data is a measurement. It is a number and a unit, and then it tells us how much of something is there. And then qualitative, it can involve a number, but for the most part, it is just a descriptive data. So really, it could be how certain organisms behave within the experiment, where you're trying to find out how many of them are affected by something that might just be their behavior within that treatment. Could be useful data because it explains what's going on as we're collecting quantitative. But this brings me to the point of something that's very important. If we were to do an experiment where the best airplane is maybe the one that looks the coolest, right? That could actually be measured. We could measure that. You might think, well, how? That's people's opinion. Well, what we can do is we can turn that qualitative data into quantitative data. That makes it just a little bit more powerful because it gives us a more descriptive idea about those qualities of that thing. So if I said to you, 4 out of 5 people prefer Frosted Flakes over Corn Flakes, what does that tell you? That tells you that 4 out of every 5 people, so 80% of people, like Frosted Flakes over Corn Flakes. That means that 20% of people like Corn Flakes, 80% of people on average like Frosted Flakes. So Frosted Flakes is better than Corn Flakes in a poll of people, right? So our unit there becomes people who like, right? So that tells us information and puts it into a quantity. So if we were judging a plane on looks, we would want to turn those qualitative data into quantitative data. So we might have to design an experiment where we poll 10 people and ask them, which plane they think is, the prettiest, which they think is not the prettiest. So to rank the planes in order of coolest or whatever it is. And once you get that, once you find out of those 10 people the rankings, then you can say you can turn that into quantitative data and say that 8 out of 10 people preferred plane A over plane B and C. So that suggests that plane A is the best plane because it looks the coolest, according to most people. So what's the best kind of data? Really, quantitative, if we're really getting down to business, is the most important data because it's numbers. It basically gives us definitive values that we can trace back to a standard, if you will. Qualitative data is also really powerful, but not as powerful as quantitative unless we take that qualitative data and convert it into quantitative data. So why is data acquisition important? An important step in an experiment. Without data, why are you even doing the experiment, right? Data is what leads us to the conclusions. Data is what helps us find the answer to the proposed question. So in this case, our data is going to show us which plane is the best. That also removes bias from the situation. So now I'm relying on the data to tell me the answer. I'm not trying to put my own answer in there. So the data acquisition is very important. Now, when we're doing this data acquisition, we need to make sure we are getting numbers and units. So if you are going to fly your planes for distance, then you need to make sure you know how you're going to determine those distances. Are you going to use feet, tiles, I don't know what you got around your yard, steps. If you do steps, try to make your steps as controlled as possible so that you have accurate counts, which is another good thing to talk about, accuracy and precision. Your feet may not be as precise as a ruler, so you might be less accurate with your data in that case. So try to make sure that you don't change shoes between throws, because that would skew your data, because now you're using different. Get my idea. So basically what you need to do is, in your head, design your experiment. What kind of data are you going to collect, right? Then you are going to set up yourself a data table to do that. Now, if I were setting up a data table, what I would do is I would go to Google Drive. Let me see if I can pull this up here. I would go up to Google Drive and I would say new. Let me walk you through this. So I would go over here and I would say new Google Sheet. And all I need to do is I need to say like plane A, plane B, plane C. And if you did more planes or whatever, that's great. I probably need to insert a column here so that I can say throw one, throw, and actually I might just say, just to make it easier later when you want to do graphs, I might just say this is going to be my throw. Alright, this would be 1, 2, 6, 7, 8, 9, 10. Now, why would I want to throw each plane 10 times? Probably just so my arm gets tired. I mean, why would you throw... let me tell you a story about basketball. This was actually in the video with the old man too, but let me tell you a story that might bring it home. Usually I get pretty excited about this story. I had this girl that was in class. This has been about 6-7 years ago. Had a girl in class who was on the basketball team. And one day I was walking through the gym, cutting through to go back to the back of the gym to talk to, I think, Coach Overstreet back in the back corner there. Anyway, as I'm walking through the gym, from the cafeteria through the gym, this girl was in there practicing some free throws, I think. And so she's just shooting around, and I get to about, I'm going to say, half of half court. So I'm definitely outside the three-point range, and I'm off the court because I'm not walking on the gym floor. And I yell to her, "Give me the rock!" Because, you know, that's what you yell. And "Give me the rock!" And so she kicks the rock out to me. That's how we say it in the 90s. And I catch the ball, and I chuck that ball up. And then I do like kind of the bouncing step after, right? And that ball goes nothing but net. Kid you not. Miraculous, right? Now, I'm walking away with my hand, you know, still in the air, and I'm walking faster than I would probably normally walk. And why am I walking faster? Because I know good and well if she says, "Hey, do that again," it's not going to happen. If I were to shoot that shot 10 times right now, I might get lucky and make one, but I'm probably going to miss all 10, not going to lie. So the reason we throw the plane more than one time, a lot of times you'll hear people say 3. Well, why 3? Well, 3's not really good when 10's better, right? What's better than 10? 100. Really, you want to throw it as many times as possible. I'm gonna say if you throw it 5 times, that's probably good. You know, let's go a little bit more than 3, but you don't have to go all the way to 10. If you want to do 10, that's gonna make your data better. You know, so I'd say go ahead and do it. So basically you're gonna collect your data. So, you know, maybe plane A on throw 1 goes 10 feet, and you would probably put somewhere in here that, you know, maybe we insert one above and we say that this is distance traveled in feet, right? So then you can fill out how far they go. Now, it is important though that when you throw, you have a consistent throwing force. So you could create an apparatus with a rubber band or something to throw them, or you could just try to be as good as you can with throwing them the same distance or the same force with your hand. I'm kind of the, this doesn't have to be perfect, so don't go crazy, but, you know, maybe you just take your hand and you're just all wrist or something, and that would give you kind of a better idea. And then you also should probably throw them from about the same height. So, you know, don't throw from way up here with one and then from way down below with the other. So have some consistency in your throw. So that's basically our data acquisition. Now, if you just noticed what I talked about, most of that last part is really what the experiment would look like, right? So our whole goal of the experiment is to collect this data, and then see what that data says. So by arranging what kind of data we're going to collect and how we're going to collect it, we've basically decided what the procedure of the experiment is, right? And that's really important because we need to know the procedure. For right now, I'm understanding, I think that your procedure is pretty straightforward. You're probably going to throw the planes and measure the distance and record that distance. So I don't need it to be too crazy. You might try to talk about, you know, be sure you know how to talk about how you kept force constant and how you kept height constant, things like that, just in your head, because you are going to need to write down a procedure for this when we go to report our lab. But I don't need a detailed deal. What I do need you to do is go ahead and let's run it. If you're doing distance, let's go ahead and collect that data. If you're doing, you know, appearance or something different, then you're going to have to collect your data a different way. Just be sure you understand the process that you're using so that you can put that procedure into words later. So for now, collect your data, and then we'll get together. Sorry, that's the phone. We'll get together and take care of the rest later. So probably next time. So I'll see you next time.